Simplifying expressions containing exponents, part 2. For this first example, the first thing I want to do is I want to distribute what's inside of these parentheses. So I'm going to leave the -4 outside of the brackets. I'm going to leave that alone, and I'm going to start with the exponents on the inside of the parentheses. So to begin with, when we have xa with a raised to the power of 3, you're just going to take your a and you're going to multiply it by 3. So then we're going to be left with x to the 3a over the same thing on the bottom. It's going to be y to the 3b. That's going to be multiplied by, so the first thing on this side, I guess we can leave it like that. The -3, we're going to multiply it by the 2a and by the 3b. So x to the -6a over y to the -9b. Now we know that the negative is actually going to switch, so for example, this x to the -6a is actually going to become x to the 6a, but it's going to be in the denominator. But because we have an x to the 3a multiplied by an x to the -6a, instead of switching it, what we could just do is we could actually add these two together. So for example, x to the 3a times x to the -6a, you just add the exponents together. So 3a plus -6a is going to be -3a. So then you're going to be left with x to the -3a on top. And then on the bottom, you're going to be left with x to the 3b. 3b plus -9b is equal to -6b. So on the bottom is going to be y to the -6b. Now remember that there's a -4 on the outside of these. So let's not forget that -4. Now we could just multiply, because this is inside of the brackets and it's all raised to the -4. When you have an exponent raised to an exponent, it's basically multiplying it. So -3a times -4 is going to be 12a. So then the top is going to be x to the 12a over -6b times -4 is going to be 24b. So y to the 24b. So it's going to be x to the 12a over y to the 24b, and that's your final answer. This next one has quite a lot going on. Let's start with these like terms on the inside of the fraction, and we're going to leave this 1 over 3k. We're going to leave that alone, and we're going to start by combining our like expressions. So on top, we have x to the 4k plus 1, and on the bottom, we have x to the -2k plus 1. We know that we can take our biggest exponent. So like, for instance, x to the 4k plus 1 is bigger than x to the -2k plus 1. So what we can do is we can subtract. So we can take our 4k plus 1 and subtract the smaller exponent on the bottom. So for instance, we're going to have, for our x's, we're going to have 4k plus 1 minus -2k plus 1. So this double negative is going to become a positive, so it's going to be 6k and then a -1. So we have a +1 and a -1 here. So this is just going to become 0. So then our x is just going to have a x to the 6k on top. The same thing with the y's. Our bigger exponent is on top. So we take, for our y's, we're going to take -k minus 1. And we're going to subtract the smaller exponent on the bottom, -10k minus 1. So this negative is going to become a positive, and this one's going to become a positive as well. -k minus 1. So we have a -1 and a +1. So that just becomes 0. -k plus 10k, that's going to be 9k. So then we have y to the 9k on top. And we still have the 1 over 3k. So since we still have the 1 over 3k in the parentheses, we can work on that next. Remember when we have an exponent raised to another exponent, we're just going to multiply the exponents. We're going to take the 6k and we're going to multiply by 1 over 3k. So this is going to become x to the 6k over 3k. Same thing with the y's. Y is raised to the 9k, so 9k times 1 over 3k is going to be 9k over 3k. So here we can see both of our k's are going to divide out. This is going to become a 2. This is going to become a 3. So then we're left with x squared times y to the third. And that's our final answer. So for this one, well, first of all, we can see that all of our variables inside of the parentheses are the same. They're all x's. So what I want to do, since these are fractions on top, our exponents are fractions, I want to make all of our fractions have the same denominator, just to make it easier to work with. There's a common denominator between these three, and that is 6, because 1 over 2n, 1 over 6n, and 1 over 3n. Actually, this is negative. So the common denominator between all of these is 6. And to get 6 from 1 over 2n, we're just going to multiply 3 on top and on bottom. And this is going to become 3 over 6n. This one stays the same, so times 1 is equal to 1 over 6n. And this one we multiply by 2 on top and 2 on bottom. And this is going to be negative 2 over 6n. So now all of our fractions on our exponents are exactly the same. So I'm just going to rewrite our problem. X to the 3 over 6n times x over 1 to the 6n over x to the negative 2 over 6n. It's all raised to the n over 2. So the first thing I want to do here is I'm going to combine these two together. So when you have the same variable raised to an exponent, we can just add the exponents together. So 3 over 6n plus 1 over 6n is going to be 4 over 6n. So then our top is x to the 4 over 6n over x to the negative 2 over 6n. And then this is all raised to n over 2. Our top exponent is larger than our bottom exponent. So we're going to take our top exponent, we're going to subtract the bottom exponent. So 4 over 6n minus negative 2 over 6n. This double minus is going to be a positive. So then 4 over 6n plus 2 over 6n is going to be 6 over 6n, which is going to be 1 over n. So then our x over n. So then this is going to become x over n. And this all raised to the n over 2. Now we have an exponent raised to an exponent, and we just multiply those out. So x 1 over n times n over 2. So we're going to do n over 2n, which is going to end up being the n's cancel out, or they divide out, and we're left with x raised to the 1/2. And that's our final answer.